one of the problems that we sometimes face when we are working with Laplace transforms of Heaviside functions is that we don't actually have a function that is in the form of a shift when we're dealing with it. So 2t plus 1, when we think about that function that turns on at time 3, it isn't a shifted function. It is not a transformation, as we would call it in algebra. It is simply the line 2t plus 1. So if we thought about what that might look like, that would have a y-intercept of, or an vertical intercept of 0, 1, and then for every 1 unit increase in t, there would be a 2-unit increase in the output. Okay, so it would look kind of like this. All right, and what we want is we want this function to turn on at time 3. Now, with our Laplace transform number 2, this says that a Heaviside that turns on at time a multiplied by a function of t that is shifted a units to the right would be this output right here. Now, normally what we would do in order to use this formula is we would take this guy and we'd shift it to the right, and it would start over here. We'd have a 0 function up until that point, and then it would start at its vertical intercept. So essentially we could think about t equals 3 as sort of an artificial y-axis or a vertical axis, because we would normally want this function to just turn on here and go from there, right, where it would be at our vertical intercept point. But what we're asking for here instead is we want to take the function 2t plus 1, and we simply want it to turn on at time 1. So whatever this value is right here, we want that function to then pick up from there. And that's a problem because that does not represent a shift of some base function. What we need to think about is what function, when shifted over 3 units to the right, you can imagine that this would look like something like this. It would be parallel to our actual line. It might look something like that. And when you shift this guy over 3 units to the right, you would get exactly the function 2t plus 3. But the question is, what would this green line be? What would this green line be? And that's where we are stuck. We need to come up with a function that we can get into the form of, hey, take this guy, shift it over 3 units to the right, you'll get 2t plus 3. And it's like, well, but we get 2t plus 3. Why don't we just work with 2t plus 3? A shifted function, when I'm saying that, is of the form, for example, if you took 2t plus 3 and shifted it 3 units to the right, you would write it as 2 times quantity t minus 3 plus 3. Okay, that would represent this blue line shifted over 3 units to the right. But we don't want to shift our line. We want to think of some line that when we do shift it over 3 units to the right, we get exactly this blue one. And we want it to have this form where we can expressly see that is a shift because, hey, you know what? That's what the Laplace transform formula number 2 requires of us. So there's a couple of ways we could do this. With a line, one way we could do it is just to grab points that we know. So like this point right here would be the point negative, I guess it would be negative 3, 1. I didn't document this very well. Say there's 2. And then we could go over 1 and up 2, and that would give us negative 2, 3. And we could use that point, we could get this into slope-intercept form. But again, we want to write it as a shift. So the way I'm going to propose doing it is that we think about the function 2t plus 1, okay? So we need to find a function that when shifted over 3 units to the right produces 2t plus 1. So in other words, we get an equality when we take some function. Now, by the way, that some function, that green line, will be of the form 2 times quantity t minus 3, right? Because they're going to have the same slope. They have to have the same slope. We're just merely shifting a line over. But what we don't know about this green line is what is its vertical intercept. We'll say that's 0, b. So we'll still say plus b on there, and then we'll just do a hunt for what that value of b is, plug it back in, and then 2 times quantity t minus 3 plus something will represent a shift of this green line 3 units to the right. Okay, so to do this, we just need to figure out what makes the two sides equal. So if I distribute over here, I'll get 2t minus 6 plus b. Now the 2t and the 2t are the same, so all is good there. We know that they have the same slope already. And then the constant here has to equal the constant over here. So I have to figure out what b should be so that 1 is equal to negative 6 added to b. And that gives me b equals 7. So my function is going to be 2 times quantity t minus 3 plus 7 is exactly what I want. I'm going to show this to you graphically so you visualize what we're doing here. Now if I plot you have to use x, 2x plus 1, there was that our blue line, our original blue line. Again, what we want to do is we just want to activate this thing at x is greater than or equal to 3. So we basically just want this. Notice that that's not our function just shifted over. 2x plus 1 again, okay? It's not just this blue line shifted over 3 units to the right. It's basically just, let's pick up the function at time 3 wherever it might already be. So our task is to find some other function, and we know it's going to have the same slope, so I'll just say x minus 3. Now, as you can see right now, 2 times quantity x minus 3 is that green line. That's not what we want. So what we'll do is we'll just plot 2 times quantity x minus 3 plus this b value. I'm going to insert a slider here, and notice that when b is 0, then we actually have just taken our function and kind of shifted it over to the right a certain number of units. It's not quite 3 units. It actually ends up being more than that. But I think it does 2x minus 6. Yeah, it ends up being shifted a little bit more than what we had. So as we change the value of b, okay, you notice that when b becomes 3, we get closer. When b becomes 5, it gets closer. When b becomes 7, they are exactly the same line. So this function, 2 times quantity x minus 3 plus b, is equal to 2x plus 1 whenever b is equal to 7. So this represents let me do this now. Just plot 2x plus 7. Okay, there's 2x plus 7. That's just without it being shifted, 2x plus 7, notice, is exactly 3 units to the right. Excuse me, starts off 3 units to the left of the blue line, and when we shift that green line 3 units to the right, it becomes exactly that blue line. So that's what we're after here. We're just doing it algebraically. And now, when we write our Heaviside function for h of t up here, so let's just go ahead and realize that this is similar to our previous examples where we can think about this as 0 and then 1 times 2t plus 1. Okay, but we're going to replace 2t plus 1 with this 2 times quantity t minus 3 plus 7. So this is, h of t is the Heaviside function, u3 of t, multiplied by the function, this in brackets, 2 times quantity t minus 3 plus 7. Okay, so when t is less than 3, then this first factor is 0, and 0 times this second factor will always be 0. And then when time is 3 or greater, then this will be a 1, and 1 times, then we get exactly this top part. Okay, the reason that helps us is because now, if I want to take the Laplace of h of t, what I'm going to do is I'm going to distribute this, and I'll have u3 of t times 2 quantity t minus 3, and then distribute it across here as well. We'll have plus 7 u sub 3 of t. We want to take the Laplace of all of that. Well, the Laplace of 7 u3t is easy. That's simply transform number 1, that's constant, times the transform of the Heaviside, which is e to the negative as, in this case, negative 3s over s, and we're done. But this first term now matches exactly the transform as that if you have a Heaviside multiplied by some function that's shifted over that same number of units as the Heaviside activates, then to compute that transform, notice that here we're going to do the Laplace of f of t. So in our case, we know that f of t minus 3, is 2 quantity t minus 3. So f of t just means, hey, take the t minus 3 and replace it with t. Okay, so this function right here, its quote-unquote f of t is 2t. And according to this formula, it says, well, the Laplace of that Heaviside times that shifted function is e to the negative as times the Laplace of the unshifted version of your function. And, okay, we have a constant 2, so we can pull that out. The Laplace of t to the first is 1 factorial over s to the 1 plus 1. And we are done now. That's the Laplace transform of this unshifted function made to be a shifted function. So we're kind of engineering this thing to fit our mold.